We tested 3 coding models with the exact same game prompt. The task was to build a web arcade shooter inside one file, same machine, same tools, same clock. Every model returned a playable game. The games made different choices and had different problems. Now let's open the evidence and see what really happened. This wasn't a vibes prompt. It was more than 1,200 lines. A verified digital fingerprint locked the exact text. The prompt fixed the core fantasy and the single-file delivery contract. It also fixed the gameplay systems, acceptance rules, originality limits, and performance targets. 37 requirements were pass or fail. Each route received 45 minutes for an untouched build. Then each route got 20 minutes for one repair. Only machine feedback was allowed, no human code edits. The 3 exact model routes are on screen. I randomized them into builds A through C before the runs. These are local route receipts. They are not vendor benchmark claims. The model names stayed hidden while the artifacts were captured and tested. The result comes from this prompt, this machine, and these files. First, the untouched builds. Builder returned a complete-looking neon tunnel and a procedural ship. It also included a title screen, weapons, boost, enemies, audio code, and visual effects. Then the automated player started the game. The page threw a real error. A missing object broke the first gameplay transition. The world kept drawing, but normal play had failed. The second build looked darker and more restrained. It loaded and accepted the same movement and fire inputs. It created enemies and projectiles. Its score and boost indicators changed. Build B completed the untouched 3-minute run with no observed browser error. The raw failure and the raw success both stay on screen. Build C produced the third playable interpretation. It was highly saturated, effects-heavy, and visibly different from A and B. Its provider session ended on a rate limit error, but the file had already been written. That distinction matters. The session failed, but the artifact existed. It decoded, accepted input, and completed the runtime test. The recorded file and its hash stay in the score. The failed provider response remains part of the stage evidence. Then came the single repair allowance. Build A received the page error and fixed the crash. Its output hash changed after the repair. The file passed all 37 machine checks. The second build came next. Its report showed no hard failure. That model changed restart audio and recycled effects. The provider then stopped on a rate limit error. The changed artifact stayed machine clean. The repair session still failed. The third build hit another rate limit error. The files stayed identical, no repairs credited. Each model got the same allowance. The outcomes were different. For the final automated pass, all 3 builds used the same browser window. Each run lasted 3 minutes. The script moved, fired, and boosted. It watched for game over. It attempted an in-page restart. All 3 finished with 0 observed console, page, or request errors. Every build averaged close to 75 frames per second. Their slower frame times were nearly identical. The first build restarted twice. The second build did not restart. The third build restarted 5 times. Restart count is an observed bot play outcome. It is not a quality ranking. The footage shows 3 different readings of the same prompt. The first build uses the strongest tunnel visuals. Rings, star streaks, blue light, and large flashes sell the speed. Its brightest moments can hide targets. The second build is the darkest and easiest to separate. Red enemies stand out against a restrained star field. The central corridor stays readable. Effects rarely cover the full frame. The third build uses the strongest colors. Magenta and bright blue fill the frame. Obstacles and particles keep arriving. The result feels busy by design. These are TonkaToyXL notes from captured frames. They are not blind scores for control, feel, or fun. Here's the boundary that matters. Automated play can verify loading and input. It records state changes, restarts, and frame health. It cannot prove control, feel, combat clarity, or fun. I did not complete the blind human scoring pass. Those human categories remain empty. This test does not name a human winner. Now we reveal the exact model names. They are on screen. The TonkaToyXL automated subtotal used 45 points. The first build scored 44. The second build also scored 44. The third build finished with a score of 43 points. The third score was 1 point lower. This is not a universal model leaderboard. It measures contract coverage and runtime reliability. It also records stage efficiency under one frozen challenge. The useful result is simple. The same detailed prompt produced 3 playable games. Their machine scores landed close. The games still looked and behaved very differently. Measure the artifact. Preserve the failures. Human taste scores stay empty until a person tests the game. Follow TonkaToyXL for more real model tests and practical AI workflows. I will keep testing these tools and sharing the real results.